So if we click on this link right here in the PyTricks folder, we'll get each of the individual Python files. Start by clicking on this bytecode curtain file here. So this basically says that you can use Python's built-in dis module to disassemble functions and inspect their CPython bytecode. So what it's going to do is if you run this function here, like this, it'll greet Dan, say hello Dan, import dis, and then it'll show all of the stuff that it is loading in its bytecode. Heading back to the PyTricks folder, check if all equal.py. So what it'll do is it's the Pythonic ways of checking if all items in a list are equal. A list says A, true, do they equal 1? Yes. And then it iterates through the list, true, and counts to see if it's the same number as those, true. So then they're all going to be the exact same. So they've been ordered from most Pythonic to least Pythonic, and least efficient to most efficient. Moving on to the next one, class inheritance. So you can check for class inheritance relationships with the is subclass built in. So we have class, base class, pass, class, subclass, base class, pass, and so it's going to check if it is a subclass as a function. And you can see the results of all of those right here. Now moving on to contextlib.suppress. So in Python 3.4, you can use contextlib.suppress to selectively ignore specific exceptions. You can import contextlib with contextlib suppressed file not found error, os remove some file, which is equivalent to os.remove some file.temp except file not found error pass. So what that basically does is it's going to suppress any file not found errors. Moving on to our next one is the CPython Easter egg. So if you want to run a little Python Easter egg, just run import anti-gravity from the Python interpreter. Emulating with case statements, emulating switch case statements. Because Python has first-class functions, they can be used to emulate switch case statements. So it runs this, dispatch if operator is add, if operator is subtract, if operator is multiply, if operator is divide, and then dispatch, return, add, and then does all of these functions, and then it runs through dispatch if just like this. Now moving on to our next one is the fault handler. So Python 3.3 has a std lib module for displaying tracebacks even when Python dies. For example, with a seg fault. So import fault handler, handler.enable. Now this will handle all of our faults through the built-in Python methods. Moving back to the PyTricks folder here, we have to find the most common element of a list, I believe. To find the most common elements in an iterable. So an iterable could be a list or anything like that. So import collections, c equals collections.counter hello world, and it's going to go through here and find the most common characters. Just like that. So there's 3 L's and 2 O's and 1 E. Not sure why it picked E as the most common, considering there's other ones that only have 1, but that's okay. Moving on to for and while else branch. Python's for and while loops support an else clause that executes only if the loop terminates without hitting a break statement. So here's our thing. The value error if needle is not found in haystack. From item in haystack if item equal needle break. Otherwise it'll say value error needle not found. Just like that. So let's look at this. 23 needle. Oh, does not contain it. And just like that. Moving on to the next one, force keyword parameters. In Python 3, you can use a bare asterisk in the function parameter list to force the caller to use keyword arguments for certain parameters. So here we are, A, B, keyword argument, C equals X, D equals Y, E equals Z, return hello. So now we've passed those through, and there are 2 positional arguments, but 5 were given, so that's incorrect, so it should be just like that. Moving on to our next one, functional argument packing. So why Python is great because it has function argument unpacking. Oh, sorry, that should say functional argument unpacking. So print my function, xyz, just like this, and it also allows you to do it just like that by using a dictionary. Moving on to our next one, running an HTTP server. Python has an HTTP server built into the standard library. Pretty handy for previewing websites. So Python 3-m http.server and we'll start up our server at localhost 8000. Scrolling down is the in-place value swapping. So there's in-place value swapping. So we want to swap the variables of a and b. So the classic way to do it is to assign a temporary. Otherwise, we can do it in shorthand by going a comma b equals b comma a. So now it's just swapping a and b with b and a. Moving down, IP addresses. So Python 3 has a standard library module for working with IP addresses. Just import IP addresses, pretty self-explanatory. And what it'll do is it'll figure out the IPv4 and the IPv6 IP addresses. Also the is versus equals one. So is versus the equal command. So A is 1, 2, 3, B is A is B, true. A equals B, C is a list of A equals C, true, because A and C are now the same. A is C, false, because A is not a list of C. Moving on. Now let's look at itertools.permutations. This is one that I personally quite like. So what it does, it'll generate permutations for an iterable. Perfect for brute forcing passwords. So import itertools for P and itertools permutations. ABCD, what it's going to do is go through all of the combinations of those characters. If you wanted to guess your phone code, let's say your phone code was 1234, what you could do is put 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 all in there, and it would guess through all the different combinations. Okay, moving on to Lambda functions. Lambda keyword in Python provides a shortcut for declaring small and anonymous functions. So basically it just allows you to do this function later on in the program code. So this return y, add, and so there's our function expressions, just like that. Moving on to our next one, list comprehensions. So Python's list comprehensions are awesome, as Dan Batter says. So values equals expression for value in collection if condition is equivalent to values equals a list for values in collection if condition values not a parent expression. So this is just a much more concise way of writing what is at the bottom here, right here. Moving on to our next section, which is list slicing. So we can use a slice syntax. It can be used without indexes for a few fun and useful things. So you can clear all elements from a list, delete the list, done. You can replace all elements of a list without creating a new list object. A equals list equals 789, list is now 789, A equals 789, A is list, true. You can also create a shallow copy of a list. So B equals list, 789, but B is not the list because it is not as what is up at the top. Moving on to our next section, we're now looking at the methods comparison. So this is class method versus static method versus plain methods. So we have our first one here, my class. This is a normal method, return instant method called itself. And then we have a class method, which returns a class method called class, and then a static method. So as you can see here, my class object method, my class instance there, class method, and static method. And then calling the calling instant method fails if we only have a class object, just as we can see right here. Scrolling back down, we go to the multiple keyword arguments. So Python 3.5 and up allow passing multiple sets of keyword arguments to a function within a single call using the ** syntax or the ** syntax. So we start by going def process data, A, B, C, and D, and it's going to print A, B, C, and D. So just like this, 1, 2, 3, 4, or here, 1, 2, 23, and 42. Moving on to our named tuple alternatives here. So what we can do is name tuples in Python. Using name tuple is way shorter than defining a class manually. From collections, import name tuple, car equals name tuple, car, color, mileage. So our new car class works as expected. My car.red, my car.color, red, my car.mileage, 3812.4. Now we get a nice string, just like that. Scrolling down a little bit more, we get to our pretty Python dicts, or pretty Python dictionaries. So that's what it looks like here. It is a normal Python dictionary, but by using the JSON module, we get a much more pretty Python dictionary. Now we can click on the PyTricks folder to get back and move on to our next one. So that's the Python dictionary get method. The get method on dict and its default argument. So name for user ID, Alice, Bob, Dilbert, and greeting user ID, hi, name for user ID there. So it goes through like this, and by using the user ID, you get to see the thing. 382, hi, Alice, greeting, hi there. So what it's doing is it'll use user ID or it'll use there if there is no value. Now moving on to our next one, repar versus stir. And so what we're going to do is see what the standard library does. So import datetime, today equals datetime.date.today. Result of string should be readable. Result of repar should be unambiguous, just like that. Python interpreter sessions use repar to inspect objects, just like that. Obviously, string is preferred because that's much more readable. Now scrolling down to sort dictionary by value. What we're going to do is we're going to use a Python command to sort a dictionary by value. So here's our value, sorted, and then using the sorted function, we can support it. So import operator sorted just like that, and it sorts it by value. Scroll back down in the page to test multiple flags. Different ways to check multiple flags at once in Python. So if x equals 1 or y equals 1 or z equals 1, print passed. If 1 in x, y, or z, print pass. And then these ones only print for whether they're true or false. So if x or y and z, print pass. If any x, y, z, print pass. So what we can see here is if x equals 1, it does not. Or y equals 1, y does 1, so that one will pass. If 1 is in x, y, or z, well, it is, so that will pass. If x or y or z is equals 1, then it'll pass, well, they do. If any of x, y, or z equals 1, then it'll print pass, so it does. So they will all pass. And scrolling down, the timeout module. The timeout module lets you measure the execution time of small bits of Python code. So you import timeout, timeout.timeout this, and the number, and it'll tell you how long that took. Scrolling back down to type annotations. So Python 3.5 supports type annotations that can be used with tools like MyPy to write statically typed Python. Def my add a is integer, b is integer, which produces an integer, return a plus b. Pretty basic. And moving down to Unicode variable names. So Python 3 allows Unicode variable names. Just like this, pi equals math.py, and just like this class spinal tap, which has a little tilde over the n. Or there's also things like emojicons. So beer emoji equals beer. However, this does not work because it is an invalid character. And scrolling down now to virtual environments. So a virtual environment helps keep your project dependencies separated. They also help you avoid version conflicts between packages and different versions of the Python runtime. So before you create one of those, you should use Python and pip to map the system version of the Python interpreter, just like that, and then create another virtual environment. Then you can follow all of these other steps to activate virtual environment configures, just like the shell session to use the Python and pip commands from the virtual environment folder instead of the global environment. You can also note how activating a virtual environment modifies your shell prompt with a little note showing the name of the virtual environment folder, and so on and so forth. There's lots of steps here. So heading back to the main page here, so those are all the PyTricks that are included in the PyTricks Archive project. Make sure to check it out on GitHub or check out the website, and then you can see them even more and dive into them a little bit more or try them out on your own in the Python interpreter.